Hello, Pre-Cal 12! Welcome, one and all, to the review study session for the last one of the semester. Oh, man, I'm having a great morning this morning. I hope you're having a great day. I'm doing this study session right now as we're kind of focusing in, mainly because, we've got a lot of things kind of coming up, one of which I'm doing it so that just in case tonight, when I normally do the study session, if my wife goes into labor, I wanted to make sure that I had this for you. So I hope this is helpful. I hope this is somewhat enjoyable, somewhat helpful as we roll through the journey and we go through past the sea of swirly, curly gumdrops. I think that's how you say it. I don't know how you go say it, but regardless, take a seat, open up your Macs, get your review out, take out your calculators, and let's get started. My goal today is to be able to make this review help session beneficial for you because I didn't know all of the questions that you might have off of this podcast. I did take a survey of specific questions that y'all had regarding some of these problems, and so I wanted to kind of go through them one by one, starting with the ones that y'all stated were maybe some of the more difficult ones from off the review. So here we go. Let's get started. First of all, the matrix capability of the calculator is intriguing because it allows us to solve for x, y, and z using our calculators there. Okay? Tomorrow you're going to have a calculator and non-calculator section. My recommendation is when you come in, let's go ahead and get started on that, largely because we have so little time with 45 minutes, and there's about 14 questions. And so let's go ahead and attack that as best as you can as you move forward. If I am not here tomorrow, I would recommend that you just go through the beginning, and as you keep going, go as far as you can towards the end with those questions. And ones like this, we should be able to do fairly quickly, where we have this idea of a matrices on number 3. And by the way, just as a heads up on numbers 1 and 2, the order of this one up here would be like a 3 by 4, where number 2 would be we have 4 rows in 4 variables with a solution. So this would be like a 4 by 5. But down here, this is much different. We have 2 rows, 3 variables, and a solution. So this is going to be a 2 by 4, where 2 is the rows, 4 is the columns, and we're simply going to write the equation and their coefficients side by side. So we've got 2, we've got 4, we've got -2, and we've got 0. On the second one, we have 3, we have 5, we have 0, and we have a 1. And so once we set up this matrices, we're going to do exactly that, plug it in exactly the way that we see it down below by going to second x to the negative first. I always move over to the edit first, the edit button on that right side. Make sure it identifies with the row by column, so this would be a 2 by 4, and then we're just going to plug it in as we see it. So 2, 4, make sure we have -2, not -2, don't use this one, but -2. If you use the minus, it'll shoot at you with an error. And there we are. Okay, so here we are. We've got our matrices here. Go ahead and go over to second quit. Remember, because we have one more variable than we do equation, our answers are going to look much different on this one, more times than not. And so just kind of keep that in the back of your mind. So once we go back to second to the x to the negative first, we'll go to the math side of this. And once we do that, we'll go down to RREF, which is row reduced echelon form, which is just simply the reducing the matrices as much as we possibly can. And then once we go back to second x to the negative first, we started at edit, we went to math, and then we're going to go to our name side, pressing enter at the matrices that I filled in. And once I press enter one more time, we get this matrices that simplified of 1, 0, 5, 2, and 0, 1, 3, and negative 1. I could be off just a little. I want to make sure. 0, 1, negative 3, negative 1. So these, this matrices that is simplified is now allows us to see that there's two equations that are here. We have this x column, the y column, z column, and then our solutions over here. So make sure that we keep it in order. Notice on number 2, like for instance on this, there is no x. So we would actually start this with a 0. So if it doesn't have that, then it would not have that specific coefficient for that variable. So the first equation over here would be 1x plus 5z equals 2. So that's the first one. The second one would be 0x plus 1y, so y, minus 3z equals negative 1. And then now what I'm going to do is I'm going to solve for x and y. I think it's fairly easy because you'll see that this is already x plus 5z equals 2. So when I get x by itself, it would be x is equal to 2, and then I'm just going to subtract 5z to the other side, right? So subtract this to the other side by subtracting it here and here. I'm going to now add 3z to get y by itself on either side, to get y is equal to negative 1 plus 3z. And since both of those answers are in terms of z, we can just then say that z is actually going to be equal to itself. And what that means is that now all of our answers are in terms of a common variable. Again, it can't solve for the actual value in this instance because we don't have enough equations to be able to utilize that to solve for it and get an integer as an answer. So we would say that those right there, x, y, and z, would be the solutions on that one there. Okay, let's go to the next one. So I got another one over here. Number 4 was another one that some people got confused with. They noticed that there was no z. So when you get this out, I just wanted you to kind of see this is 1, 2, 0, 1, 1, 6, 3, negative 2, and 8. And the simplified RREF of this in my calculator would actually produce the following. Okay? And this is where people struggled just a little bit with identifying what was going on. Well, this would be x is equal to 0. This one would be y is equal to 0. This is solutions, right? All the solutions. But then this would be 0 equals 1. So since I can't have an answer of these two, that's okay. But since 0 does not equal 1, we would say that in this instance, there's no solution for this because 0 cannot equal 1. And we would say that this would be inconsistent. When it's no solution, we could also say that this is inconsistent. Okay? Every other time, whether it's infinite solutions or one solution, we would say it is consistent. But in this case, no solution is inconsistent. Okay? Number 5 is another interesting one. Number 5 is one where I could actually solve algebraically or by calculator. You'll notice that on number 5, I could, if I desired to do this, add y to get x is equal to y plus 1, which allows me to then substitute y plus 1 in for x, okay? Which would be then y plus 1 squared plus y squared equals 25. Sorry, that's separate, right, over here. And then I could square y plus 1, I'll distribute 1 to each, right? And then add y squared and go from there. However, I could also use my calculator to be able to find these as well, since this is also something that I could use the calculator for. So I could state, going back to the previous example of x equaling y plus 1, I could actually change this part around to get it to where it was y equals x, and then I just subtract 1 there, okay? To get y by itself over here, to use it in my calculator, I could subtract x squared to get y squared is equal to 25 minus x squared. And I think a lot of us remember kind of off the homework slash kind of off the quiz that I could also, when I square root this on either side, I would get y is equal to plus or minus the square root of 25 minus x squared. Now, real quick, remember, I'm not able to take the square root inside of, or can't take the square root of 25 or x squared, mainly because there's that negative that's right in between. So our calculator part would be, I think it's x minus 1. Okay, so we're going to have kind of 3 here. I'm going to clear these out. So the first one is x minus 1. And the second one was the square root, 25 minus x squared. And then the bottom one, kind of put this back in. Oh, hold up, my fault. This would be negative, and the same thing, square root of 25 minus x squared. Now, when I press graph, you'll be able to see this line going through, and then a semicircle on top, which is the positive, square root of 25 minus x squared, and then the bottom, which was the negative version of that. So we're looking for where these two intersect here and here. Again, I can find it algebraically, but if I wanted to try to find it using my calculator, I'll go to second trace again, go over here to number 5, which is our intersect, and let's say I want to find the first curve being the blue one. I'll just press enter just because I've got that there. The second one being the red one, which means I'm going to try to find that point of intersection. And then my guess, if I want to try to move over, I could do that by kind of going close. Doesn't have to be perfect. But pressing enter allows me to see that first point of 4, 3 as my intersecting point. Now, what about the second one? The second one's kind of the same idea, except now we're going to go to intersect again, because I see that there is a second one. I'll press enter at the blue one, but notice I don't want the red one here, because I want to find where it intersects with the one that's in black down below. So if I keep pressing up, notice I go from the red to blue to black, and I'm just going between. I haven't pressed enter yet. So I want the black one, so I'll press enter once I've come to that one. And then the guess part will be over here on this left side. Again, as long as it's close, it's fine. You'll notice that that would be the intersecting point of -3, -4. So our solution was -3, -4, and I think this other one was 4, 3, if I was reminding myself of that. And that's how we would attack number 5 there, and how I would use my calculator. Though algebraically, can do that as well. Okay? Good stuff. Number 6. Ooh, yes. Number 6 and 7. I will say number 7 is also a calculator question. I can look at that one here in a second. In fact, let's do 7 since we're on this calculator theme. Notice that we have supply and demand. Remember that in supply and demand, P is the same as the Y axis. So this is really Y equals this. So we're just going to plug in our equations of Y equals here. So we're going to come here. We'll clear all 3 of these. Okay. We'll go 220 minus. Make sure we get the 3 zeros there. So 0.000 x. And then 90 plus 0.0003. Okay. And then x. All right, so we've got, let me go back up here because I think I forgot this. 0, 2x. 2x? Yeah, I think that's good. Make sure that I've got it plugged in right. All right, here's the graph. Let's see if it actually shows it to us. It doesn't look like it actually shows us. So if I ever see that I have 2 options, I can either try to zoom out with number 2. I can also go to, if I go like down here, you'll see this thing called zoom fit. Sometimes that will work. If I press enter, let's see if it'll fit it in or allow me to see this. Yeah, that didn't work at all. That was awful. All right, let's go back here. So zoom standard was right where I was. So we'll come here. Let's go to zoom, the zoom function, and let's go out. So that'll be number 3. So if I go zoom out, and when I press enter right now, it's gonna like take a step back. So let's see. If I take a step back, does that do anything for me? Yeah, it does nothing for me. Press enter again. Let's see if that does anything for me. All right, there's one line. I think, let me see. Oh, look. It's coming, right? Notice it's just a very subtle increase and decrease here. We want to see what happens over on this side because I'm guessing that's where it's going to intersect over there. Before I do that, though, let me see. Okay, I think I'm good so far. Okay, let's go back to zoom. Okay, we're going to zoom out again, except let's go to zoom out. It's way out there, isn't it? Yeah, we're just going to keep rolling here. Zoom out there. There's the first one. You'll see it's coming, right? It's coming. It's just really subtle because the slopes are so small. That's why that's happening there. So if you're like, Coach, why is that happening? It's because the slopes are so small. And you're going to see that if finally, I think I can find it right now. Let's double check. Let's go to second trace. If you still, even though we can't see it, we can go to intersect here. And we could just simply go over to the right side. And you'll see it's on the blue. Just press enter, and then it hops to the red, press enter. And then my guess, I'm just going to press enter again because it's where it needs to be. And yeah, so nothing. Let's try this one more time. Let's go to graph again. We could zoom out one more time. And as you can see, you're just trying to play by ear, see where this is at. So small, I know it's tough to see. Let's try it one more time. Let's go to second trace. Let's go to 5 as intersect. Press enter, enter. See if that'll do it. All right, let me make sure. Did I plug that in right? Let's see here. Let's quit on that. Let's quit there. Let's see y equals what we got. 220 minus 0.002x. 90 plus 0.0003x. Since there's not a square here, we're trying to find the point of equilibrium. If that happens on your calculator, you know what? We'll do this. Because it's such a small difference, this number is going to be really, really big. And so we're just going to solve it the way that we know how, by setting them both equal to each other. And really that's what you're doing when you're solving for the point of equilibrium, or where they intersect. So we're just going to simply get both of the x's by itself. Get 0.0005x when I cancel here. Subtract 90, so this is 130 equals 0.0005. So we're going to divide by 0.0005. So again, using a calculator, this is probably the easier method. Notice this does not have a squared on it. So I think a lot of times this might actually be easier to do by hand. I was trying to show you how to do it on the calculator, which you could if it wasn't so fine, so small. So I think it might be easier to actually do this. Because as you can see, you have 260,000. That means that this point will actually intersect over here at 260,000, which is very, very large for x at the amount that I would have to sell to be at a point of equilibrium, right, for my supply and demand. So x is the number of units that I would sell. And then to find what the price would be of P, I could plug it into either equation. So I could say 90 plus 0.0003 times, and then just plug this in for x. So if I came back here, I could just take, let's quit out of there, I could take this number, multiply by 0.0003, and then I would just add 90 to it. I should get, yeah, there we are. I'm going to sell these units because this equals P. P would be equal to $168. So the X would be 260,000 units, where the price I would sell it for would be $168. Let's do this. This one specifically, even though it's calculator section, go ahead and on this one, feel free to do it like what I just did instead of trying to plug it in like we've done before. But that'll work. That'll be a way to be able to help solve for it there. All right, number 6, another very good one. It says, again, I always read the last sentence as we're moving forward on these word problems. It says, how many units must you sell to break even? All right, so what we've got is this idea of break even. Different than supply and demand. Supply and demand is, what am I going to sell it for? What's the demand curve? What's the supply curve? And then we set them equal, and where they intersect, we call the point of equilibrium. But up at number 6, we have what we call cost and revenue. The break-even point means where does the cost equal my revenue? How many do I have to sell to finally break even within my company? So we have a small business. We've got Coach Jay's Cafe. The coffee shop is open, and he's invested $5,000 to produce items that sell for $9. Okay, so we've got the cost that I have is $5,000 initial investment, and I sell these for $9. Now remember, in selling these for $9, that means every time I sell a coffee, someone's paying $9 for that. So the revenue that's coming in is $9 times the amount of coffees that I've sold. So X would be items, whatever it may be. I've stated that they're coffees that I've sold. But X would be whatever the item that I am selling there. Now the problem is that each unit is produced for $7. So really I'm not getting $9 in my revenue. Some of you might be able to do this in your head. I'm really only getting $2 in terms of what I'm getting from each of these. But you could do that. You could just say, okay, this is 2x, or I've taught it as I am paying $5,000 for the initial investment plus $7 for every coffee that I produce. So 5,000 plus 7x equals 9x. And so where does cost equal revenue? That would be my cost of 5,000 plus 7 for every coffee I sell, and that equals 9x for what I sell it for, or the revenue I bring in. So when I subtract 7x, some of you did this in your head, which is fine. I'd say I'm gaining $2 for every coffee I sell. I divide by 2, which states that I would have to sell 2,500 coffees to finally break even. And that's what we would state there. As far as my cost is concerned, I could then kind of go up to my cost and plug it back in, but really it just says how many units must I sell, which in this case would be 2,500. Very good, very good. That's a good one there. That was number 6. Number 8, 9, and 10, we're starting to move more towards the solving, by normal methods, whether that is by substitution or whether that's elimination. 8's a great example of one where I would state that in this one, it might be easiest to be able to eliminate these y's as I look at this, because I've got x squared plus 2y minus 5 equals 0. The one thing to remember is when I have an x squared, there's a possibility of having 2 sets of answers. So being leery of that is very important. So like on the top, if I were to multiply this top part by 2, you'll notice that we can then cancel out the y's. I would never cancel out x squared, because then you'll only have one answer, and that can sometimes be a problem. And so for here, let's just say that this is 6x squared minus 2y minus 2 equals 0. So that's gone. So I'm going to combine this one and this one to get 7x squared. The y's cancel. minus 7 equals 0. And then we can just solve like we would normally. Add 7 to either side. By the way, I appreciate you watching the podcast tonight. I know that there's a lot going on. I would just say keep finishing strong, all right? I appreciate y'all. I love Pre-Cal 12, and I appreciate y'all. When we square root a squared, remember that we have plus or minus on either side, on the right side. So this would be x is equal to plus or minus 1. So to find what y is, we have two different answers where x is going to be 1, comma, and negative 1, comma. And to find y, we can just plug them back into our equations where it could be either one. But let's say I do it up here. That would be for 1, just the value of 1, be 1 squared, which is 1. 1 plus 2y minus 5 equals 0. So then 1 minus 5 is negative 4. Add 4 to either side. And I get 2y is equal to 4, and I just divide, and I got 2 here. When I plug in negative 1, I think I actually get the same thing. So I think I get 1, 2, and negative 1, 2 as my answer here. And that would be the two locations where they would intersect. Okay? Down below, one thing to remember on numbers 9 and 10 when we're going to it is if I ever get, and again, I would do elimination on this one. Trying to think, yeah, elimination probably on this one where the top, maybe I multiply by 3 and the bottom by negative 2 if I were to take out x's. But once I get to this, by the way, the answers are online. If I produce in both of these an answer that's 0 equals 0, this is all solutions or infinite solutions. If I get 0 equals 2, that is no solution. This would still be consistent. The only one that's not consistent is when there's no solution, because if I were to draw a graph, it would be where there are like parallel lines, which means there's no intersecting point. The picture for all solutions would be, actually, it would be the same graph. So if this was the first one, the second one would actually go right over top of it. And that's where we get all solutions as our answer there. Okay? So look at those ones as we're moving forward. The last three that I wanted to look at are numbers 13, 15, and 16. Remembering that on number 12, the easiest way to get rid of this decimal is if I were to move the decimal over one time, just make sure it's consistent for each one. So here and here. If you move it over twice because the decimal was further in, that's fine. Just make sure it's consistent for every part within that specific equation, and then it makes it much easier to solve off that one. All right, let's go to 13. 13 is one where a lot of you maybe do not like fractions, and I understand that. Fractions become a little bit tough. But the easiest thing to do on fractions is just to get rid of it. It's not even to worry about the fraction part of it, but just to get rid of it altogether. So like on 13, if I were to do this, I would just multiply the left side by the common denominator if I were to create a common denominator. So what is the number that I could multiply by for each part here, here, and here that would get or eliminate 5 and 2? And I would say the CD, or the number that would get rid of it, would be 10, right? All right, and we're going to talk over that in a second. What number on the second equation could we multiply by that would get rid of the bottom number of 4? And I would say that in this instance, the best part would be, because it's 4 here, multiply each of these by 4. I'm going to give you just a second to work on that really quick. I had something come up, so I'm going to go and get that really fast, just in the middle of the podcast. So check that out, multiply by that common value, and then roll from there. I'll finish it in just a second. Okay, I'm back with you. Sorry about that, y'all. If you needed to, I guess you could have fast forwarded the video here. What you're going to do now is you're going to multiply this denominator, right, the 5 and the 2, by the 10. Now, as long as this is consistent and I do it for all of them, I can do it as long as it's the same equation that I multiply that 10 value by. So if I were to do this, I would get over on the side 20 over 5, and some of you can actually already reduce this, which is fine, minus 10 over 2y equals 40. Notice, once I simplify, this would be 4x minus 5y equals 40. So this would be equation 1 right here, okay? The next one down below, the 4 can cancel, and you can kind of do this a little bit easier. 4's can cancel, and then 4 times 7 is 28. So what I got was x, this is equation 2, I don't want that to be confusing. We get x plus y equals 7 for the second equation. So noting that I can also use some elimination here, if I multiplied each of these by 4, oh, by the way, this was 28, wasn't it? My fault. So that was already 28 from over on this side. Don't forget to multiply by every value. I'm going to multiply by 4 on each of these. And then this 28 I'll multiply by 4 again because it was already multiplied by 4. But in order to eliminate, this would end up being 112. So 4x minus 4x cancels. Negative 5y plus 4y is negative y. And that would equal, negative y would equal 40 plus 112, which would be 156. So I'll change this to where y is equal to negative 156. I don't know why that sounds funky there. Let's see. Got my answer sheet out. It should be right below on that side there. Let's see what I got. 4x minus 5y. Oh, I thought that was a negative. Dadgummit. Okay. My apology here. So coming back on this side. So all this is not a negative, because of the mess that I put here. That's why you shouldn't do that, I guess. Put a negative here, plus here, and a negative here. That's much better. So now we're canceling, right? So now we get 9y equals, making sure I've got 9y equals 152. Making sure I'm combined right. I think this thing threw me off up over on this side. Nine y equals all right, I'm just going back through and checking my work here because what I did on my answer sheet compared to this is a little different, which is okay. But I got 4x minus 5y equals 40. Oh, yeah, I'm subtracting. That's why. Oh, my word, my signs are off, y'all. And once I subtract by 40, I should get 72. There we are. Divide by 9, y is equal to 8, okay? Once I get y is equal to 8, I could simply plug it in. It doesn't matter what one. Maybe the easier one is x plus y equals 7. That was here before I multiplied by 4. And if I plug 8 in for, or this is equal to 28, plug 8 in for y, and I get x is equal to 20. My apology on that one. The big thing is just making sure that you show that work and you don't do like Coach J and mess up on how you plug it in from there. The next one that we're going to hit on, numbers 15 and 16. 15 is maybe a little bit easier, and I'll start with this one by just giving you a quick heads up on maybe what you need to be prepared with on this one. I would state the first part of the process of either eliminating and substituting with systems of 3 equations is to, if I'm doing this by hand, I would pick one and go with it, at least for the beginning. So for me, I like to do a substitution by maybe isolating one of the variables by adding y, subtracting by z, and then I'll plug it in for the other two that's here. But once I've stated that, okay, x is equal to 6 plus y minus z, which is what I've got here, I've used the first equation, and now I could simply plug it back in for the second and the third equation, and then simplify and go. My goal is to get two equations with two variables, and I can do that by starting with that substitution process. An example of this would be number 16, which I'll wrap up with. I want to get one variable by itself, which it looks as though you could use elimination maybe on 1 and 2, maybe like 2 and 3, where I might just take out the z's on both of those. But for me, I always like the substitution part, at least at the beginning. So if I looked at the first one, I'm going to use it by getting x by itself to get x is equal to 6 minus y minus z after subtracting both of y and z to the other side. So the first equation is done because I've got it already isolated for a specific variable. So then on equation 2, and I'll do equation 3 over here as well, do it in a different color so you can see it. On equation 2, I'm going to put in 6 minus y minus z in for x. So we got 6 minus y minus z in for x. That's in parentheses. And then you've got plus 4y minus z equals 2. That's left over. And then on equation 3, we've got 3 times x, which would be 6 minus y minus z. And then I put in minus 2y plus 2z equals 3. So the part that I substituted in for x, this was x, but now I've plugged in here and here for the second and the third equation. So now let's simplify by adding like terms together. We'll start with 2 because there's nothing I need to distribute, making negative y plus 4y, 3y. Negative z minus z is negative 2z. And then we obviously had this 6 that was on this left side. Let's get it to the other side. That way we've got it. So we've subtracted by 6. We've got now 3y minus 2z equals negative 4. Okay, hold on to this one. We'll hold on to that part. The next part over on number 3 is we're going to distribute this 3 to each part to make 18 minus 3y minus 3z as we distribute to each one. Make sure you remember to do it to each part. Equals 3, and then now we're just simplifying. So we've got the subtracting 18. We'll do that just so we've got it. It's got negative 15 on the right. And then you've got negative 3y minus 2y, which is negative 5y. Negative 3z plus 2z is negative z. So this is our second equation. So now we've got 2 and 3 that have been simplified. Now our goal is now to put it together. So I'll maybe bring this one just so you can kind of see. Bring this one to this side under here. So this was the simplified one. We've now got 2 variables and 2 equations. Looks like elimination might be the best, although you could substitute with z, I guess. So let's multiply the top by, top will multiply by negative 2. So if I did that to both parts on the left and then the solution on the right, the new equation, which I'll put underneath right over here, negative 2 times negative 5y is 10y. Negative 2 times negative z is 2z. Negative 2 times negative 15 is positive 30. And what we've got now is 3y. We've got the z's that cancel, right? That's the goal. We've got 13y equals 26. So we divide by 13. And we get the first one, which is really the most challenging one. Once I've solved for the first one, it makes it much easier to then say, okay, y is equal to 2. So what can I substitute back in for to solve for z? I would say, coming back over on this side, if I bring this down, I get 3 times 2 minus 2z equals negative 4. So I've got 6 minus 2z equals negative 4, subtracting by 6. And what I get would be negative 2z equals negative 10. Divided by negative 2, z is equal to 5. Okay? So we've got y and z. Getting x is our last part, which I see up here we've already got x is equal to, where this would be if I had substituted in 6 minus 2 minus 5. 6 minus 2 is 4. 4 minus 5 is negative 1. So x is equal to negative 1. And there we are for x, y, and z. Hey, I hope this podcast was helpful for you as we navigate through, hey, how do we use these systems of equations to solve? We're going to do some stuff in class. I hope to be here on Friday for your test, but if I'm not, do the very best of which you're able to do there. Start with the calculator section and then maneuver to the non-calculator section. All right, have a great day. We'll see y'all. Go Spartans. Have a blessed day. Bye.